Well, now we get to my favorite graph to make, the box and whisker plot. I don't know if I can tell you why it's my favorite. I just like it. There's a lot that goes into it. We need to come up with a 5-point summary, and we'll explain what that is. And then there's this thing called the IQR, which stands for inner quartile range, which may sound kind of foreign to you now, but we'll make sense of it. So as we go through this, we're going to look at the data set we've used in other examples, which are the high temperatures in Des Moines for 2025 and 2026 in the month of January. And so each data set, there are 2 data sets, each of them has 31 entries in them. And what we're going to need to do to make a box and whisker plot is look at our numbers arranged in order. Least to greatest would be the best. And so I've provided that over here. We're going to look at these. And let's jump right into the 5-point summary and how we would form that from our temperature data here. Okay, so we'll just label this 5-point summary. And we'll look at 2025, but we'll also look at 2026 eventually. So I'm going to leave room for both of those. Now, the 5 points, the things that we are interested in are the minimum, okay, something called Q1, and we'll talk about what that means in just a minute. Then we're interested in the median, and then another thing called Q3, and then the maximum. Now you may be asking, where's Q2? Maybe you can figure that out. All right, well, let's start with the easiest part of this first, minimum, maximum, because we can look at our data if it's a range from lowest to highest and see that in 2025, our minimum high temperature was 8, and the highest one, the maximum, was 55. Okay, so I will put those in there. Now, the median we should know how to find as well. It is the one in the middle. Now, there are 31 days total. That's an odd number, so there's going to be just one in the middle. If we divide that 31 in half, we get 15.5. And if you round that up, that tells you the one in the middle will be the 16th down in the data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, now if that had been an even number and we had gotten like 15, then we would have taken the 15th and the 16th and found the average of those. But as it is, it's the 16th down. It's also the 16th up. So if you start at the bottom and count up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we can verify that that is the median. Okay, now what that median value has done is split our data set in half. 50% lies above it, 50% below it. And what we're going to do next is find the median of the upper half of the data. All right, so what is the median of this upper half? Well, you also have to consider, is 31 a part of that upper half or not? And I've heard this argued both ways, to be honest with you. So I'm not going to fault you one way or the other. Some people like to include the 31 in both the upper and the lower half. Some people like to say, okay, we've used it, we're just not going to count it in either half, and we'll just leave it out. I'm going to do the leave it out method this time. That gives us 15 data points above it. Okay, so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, and there's my median of the upper half. 1, 2, 3, 4, 5, 6, 7, 8. I'm calling this the upper half because it's upper, even though the temperatures are actually lower. So call it what you will, but this is the median of the upper half of the data. We call that Q1, and that stands for first quartile. Well, what's a quartile? Well, it's a fourth of our data, and we've just divided half of the data in half. So this represents the first quarter of the data, and that's that point and what that symbolizes. So if we come down to the median, that's actually our second quartile. We just always call it the median. And then if we come down to the lower half of the data and find the median of the lower half, 4, 5, 6, 7, 8, that is our third quartile. And that distinguishes where the third quarter of data ends and where the last quarter begins. And then we reach our maximum value down here. So our Q1 was 23, our Q3 was 40. I'll go ahead and add those to our list. And then we also had our median, which was 31 that I forgot to write on there before. All right, so now we have our 5-point summary complete. We can actually make our box and whisker plot here. Before we do that, I just want to talk about a little bit of the math involved because I mentioned this thing called the inner quartile range. Okay, we usually just call it IQR. And that is calculated just like we would calculate the range of a data set. But instead we take Q3 minus Q1. So in this case, it would be 40 minus 23, or 17, okay, for 2025. Now, the range of the data, not the inner quartile, but just generally speaking, the range of the data is just the highest value, so the max minus the lowest value. So in this case, it would be 55 minus 8, and that would be, oh, what would that be? 47? Okay. So, and again, we're talking about degrees here, degrees Fahrenheit. Why would we use one over the other? Well, range sometimes gets inflated because of outliers. So if there was a day where it was particularly cold or particularly warm, it might misrepresent what temperatures were actually like for the whole month of January. But inner quartile range does not take into account outliers. And so it's a more stable measurement of how things actually were, as long as we understand it's describing the middle 50% of the data. Okay, well, that's how you calculate it. But to make the box and whisker plot, let's go back there now. What we're going to do is make a number line, and that number line is going to have to contain your lowest and your highest values. Now, because we're making this for both 2025 and 2026, I'm going to consider the lowest and highest values there. And it seems to go from 2 to 60. So I'm going to make a number line that maybe it starts at 0 because there was no high temperature less than 0. And we'll just go up by 10s here. So 10, 20, but we're going to make things evenly spaced. This is where graph paper can come in handy. 50, 60. Okay. And then I'm going to look at my values here. And for each of these values, I'm going to give a little vertical tick mark above their place on the number line. So the minimum was 8. I'm going to put a little vertical mark where I think 8 is. And then Q1 is the next number. I'm going to put a little vertical tick mark there at 23, and then 31, and then 40, and then 55. All right, now we're going to connect some of these things. So the middle 3 tick marks we're going to turn into a box. And we do that by connecting, oops, I kind of missed there, but we do that by connecting the tops and bottoms like that, okay? And then we're going to reach out to our whiskers at the middle of those segments. All right, so that is a box and whisker plot. The box represents the middle 50% of the data, and the whiskers represent the lowest 25% and the highest 25% of the data. Let's compare that to 2026. So again, we have a little bit of work to do. Our low was 2, our high was 60. And the nice thing about this is because it's the same size data set, I can just come over here and I know automatically that that's our median. Let's see, this is going to be our Q1 and this is going to be our Q3. So I don't have to think about that too much. So 20, 30, 41. All right, and then we're going to do the same thing up above here. So I'll use a different color for 2026. We had a minimum of 2, and then we went to 20. and then to 30, and then 41, and then all the way up to 60. All right, and so I'll make my box. I want to make it fairly similar in nature to the one below it. Okay, so what can we tell from a box and whisker plot? Well, first of all, let's label some things here. This is 2026. This is 2025. Let's label this high temp in degrees Fahrenheit. And then we can say Des Moines, high temperature in January. Okay. Maybe we can say daily high temperature. Okay, so we know we're talking about all the days in January. All right, well, what we can do is compare the distributions between the 2 years. Were they similar? What was different about them? Look at those median values, and you notice they're very close. One was 31, and this one was supposed to be 30, so it should probably be moved over just a little bit. I just missed it. But very similar medians, and the middle 50% is pretty close. In fact, what we can do is go back and calculate the interquartile range for 2026 as well. So for 2026, it was 41 minus 20, so 21 degrees. And if you notice, the middle box for 2026 is a little longer, but also the whole set of box and whisker is longer, which means there was a larger span of high temps in 2026, so more variety than in 2025. And then we can say, okay, what about the lowest 25% of days? Well, there seemed to be more variety in 2026, but it was still fairly spread out in 2025. These are two pretty evenly spread out box and whisker plots. Sometimes you'll see it like one part of the box that's really close together, and that means that 25% of the data was really all tightly packed, but it was still an equal amount of days to the rest of the sections. So anyway, that's a box and whisker plot. You make it from a 5-point summary, and from that 5-point summary, you can also talk about interquartile range, and you can compare it to range. I know we didn't calculate it for 2026, but that's okay. So yeah, hopefully that is helpful information.